So, welcome back after the lunch break and after the panels. This session is about to discuss the results, to bring together the results of the panels and to discuss the results and to compare our question if the grand series have become obsolete, looking to the different disciplines. When preparing this event, I talked to a lot of people about the question if theories have become obsolete, and the results amazed me a little, because people from natural sciences told me that's such a typical philosophical question, or it's such a typical question from humanities. It's not a question for natural sciences. And then I went to people from social sciences and from humanities, and they told me, that's such a typical natural science question. It's not a question with which people from humanities or social sciences are primarily concerned. Only philosophers told me, no, that's serious. That's really a serious and a hard question. So, we will see. First, I'm going to present you our panelists, which are mainly from the panels we had in the morning. Then we will have a discussion here on the panel, and afterwards, of course, we will also have time for questions from your side. I start to my left with Professor Carlo Beenakker. He is a professor of condensed matter at the University of Leiden. And as I learned from his website, he knows all about the quantum world, which is a very actual topic indeed. He looks at the behavior of quantum particles and considers how this knowledge can be used to develop new technologies. He is currently considering how to build a quantum computer in the lab. And he will later on tell us about the big data machine learning to quantum computing panel. Beside Professor Carlo Spoerhase is professor for German studies at Bielefeld University. His research interests are materiality and formats of literature, aesthetics of scaling, which means he's concerned with very long, big books, and the connections of literary research and theories of society. Angelika Epple is a professor of history at Bielefeld University also, and among her research interests are history of globalization, the Americas as space of entanglements, practices of comparison. In fact, she is a spokesperson of the Collaborative Research Center Practices of Comparing, Ordering, and Changing the World. She is also Vice Rector for International Affairs and Diversity at Bielefeld University, and she has also been member of the organizing committee for this conference. To my right, Professor Tobias Werron is professor of sociological theory at Bielefeld University, and his current research topics are sociological theory and globalization studies, sociology of competition, rankings, violent conflicts, and nationalism. And Professor Armin Gölzhäuser is a professor for theoretical physics and teaches physics of supramolecular systems and surfaces. His research is focused on the fabrication, characterization.
Experimental physics.
Okay, sorry. He's a professor for experimental physics and teaches physics of supramolecular systems. It's true, that doesn't sound very theoretical. His research is focused on the fabrication, characterization, and application of low-dimensional nanostructures and functional materials, and he has a strong interest in the technological application of nanostructures. Okay, then maybe we start with the reports from the different panels. Let's see what panel A was. Professor Werron. You are reporting on the panel Theorizing Contemporary Society, Challenges and Perspectives. What about the grand theories and their role in your panel?
Yeah, I've been thinking about how to turn this into a problem for us because I think at least most of us are actually believing in theorizing, in maybe even at least drawing on the tradition of grand theorizing in sociology. But actually there's a topic came up in the discussion that could be interpreted in the way that we say we don't actually have enough large-scale theories or put enough effort into constructing such theories, in the sense that we were talking a lot about globalizing social theory, against the background that what we have is a long tradition of methodological nationalism in the social sciences. That is, theories that are drawing their problems, their main concepts, their main ideas from a perspective that is built around nationally defined, maybe even politically defined problems of the social. And in a sense, that's not large enough, right? If you think about theory in terms of globalizing social theory, if you think, for instance, as many of the members of our panels do, that you can understand national developments only as part of large-scale world historical development. Each national history is part of many such histories. There is coping involved, that one history might influence the other. There are networks across national borders involved, and all that kind of complexity that is often missing in the social sciences. So in a sense, social theory and grand theory is necessary if you understand it as global theorizing, in order something that we actually have to build. It's not obsolete. We actually are trying to achieve it in the first place. So it's in the future rather than in the past, in a sense.
Okay, thanks a lot. So it's a debate between national and global theorizing and the question of the past and the future and the present. Thanks for the moment. Professor Spoerhase, you're reporting from the panel Textkulturen der Gegenwart, Textual Cultures of
Yes, just a very short report. We talked about digitization and how digitization changes our concepts of textuality, and we used theory a bit in the sense Nancy Cartwright has used it today. So we didn't use theory in the sense of this capital T theory, this theory which has been very influential in the humanities in the sense of the works of Foucault or Derrida or Lyotard and so on. So these theorists with their large universal ideas about how culture actually works. So this was not the concept of theory we used, but it was rather the concept of theory related to what kind of methods do we use, what kind of instruments do we use, what kind of objects do we actually tinker with on a day-to-day basis, what kind of concepts are the most important concepts, and how does all this change in the concept of in the context of digitization. So this is basically what we talked about, and it turned out that of course there's a lot going on in the humanities, and it's not only, maybe this is one point, it's not only that we now have new paradigms or new perspectives on textuality, but we also now are at a certain moment where we sort of review everything we have done in the last 100, 200 years and try to ask new questions like, what was a manuscript actually? We knew what manuscripts were, right? So now we seem to think, no, maybe we didn't know what manuscripts were, because we have to transform the manuscripts into a digital context. So we start to rethink the concepts, the methods, and the instruments, the infrastructures we use in the humanities, starting from this sort of large digital moment in which we live right now.
Okay, thanks a lot. It's maybe one of the most fascinating aspects of digitalization, that it forces us to rethink how problems were posed, how answers were given, how biases are defined, and all this, yeah. Okay, thanks for the moment. Professor Beenakker, from the panel of machine learning and quantum computing.
So this was basically in all the three talks, an issue of is creativity something specifically human, or could a machine have creative thoughts? We always thought, computers were like stupid, and now we learn that they become smarter. In my own field of physics, there is now the question, can computers discover physical laws? Could a computer discover quantum mechanics? Could a computer discover Newton's law? Could a computer somehow, just by looking at the data, come up with the idea that the sun revolves around the earth instead of the other way around? And the answer is most probably yes. And so this whole boundary between humans, which are creative, and computers, which are just number crunchers, that's a boundary which we'll have to get used to it, that it's not as rigid as it is. Still, I would not, and I think this was also not the intention of any of the speakers this morning, say that this is the end of creativity, the end of theory. I'm not quite sure how I would use theory, but somehow in my field, theory is the creative act of interpreting data. And that was, so what we see now with artificial intelligence is that machines are interpreting data, are recognizing pictures, can tell a cat from a dog, can tell a husky from a wolf. That was one of the items this morning. And they're still a bit childlike, but this will improve. So I think, yes, some of the theorizing will be done by computers, and we'll be using computers as a tool, as we have been using computers since they first arrived. We've been using them as a tool, and we'll work with them, and so we're not scared of that. And so no end of theory, but yes, computers, quantum computers, will take over things which we always thought were uniquely human, which is the creative act of interpreting data. They are already doing that, and they will do that. Translate, interpret your questions which you ask to your computer, make an appointment or whatever. And that's kind of okay. We're used to crossing borders and identifying things which were black and white and saying now they can be both, like the qubit, right? Both 0 and 1 at the same time. Okay. So that's what I want to say at this moment, and perhaps there will be more.
Thank you. So on the one hand, computers are only instruments, but on the other hand, they are very powerful instruments, forcing us to rethink a lot of things we have done before. Professor Gölzhäuser, from the panel Interdisciplinary Models for Complex World.
Yeah, I must say, sorry, our conference now lasts already 3 days, so we don't only have 3 talks, but we have embedded this university conference in an own conference of our so-called Breaking Confines initiative, which is a group of scientists from different disciplines at Bielefeld University exchanging information about modeling in various disciplines. So in some sense, maybe theory is a big word. We are more like the craftsmen of science, while using models as opposed to, let's say, the real big theory like relativity or quantum mechanics, using specialized theories, little models that fit much better to solve certain problems. And I must say, I think most of our panel got a lot of motivation of the 2 keynotes yesterday night and this morning. I think Nancy Cartwright pointed it out very well by showing that you can do these big quantum gravitation experiments also only if you read the manual of how to polish your lenses and how to get your experiments right. And now the major aim of this Breaking Confines is, and what it makes it unique, is bringing these craftsmen from these different disciplines together, exchanging their recipes, their models, and then hoping that one is able to learn something from the other. So today's panel here within this conference, which was panel D, I think, was part of it, and it contained 3 talks which were really around this tradition. There was one from chemistry, from polymer chemistry, and there was one from biology, from behavioral biology, but there was also a philosophical talk by Paul Humphreys, which was quite inspiring because he gave us an idea in the craftsmanship how the machine learning thing will eventually work. And in the following discussion, we also learned, I think, a lot about what craftsmen can learn from these new machines. And so I think our whole panel and I must say the conference we have been now in for about 3 days, so I'm a little exhausted by that, is more or less, I would say, I'm not a theoretical physicist, I'm an experimental physicist. It's more about hands-on and craftsmanship experience, how to help to create the tools necessary maybe to gain some insight and knowledge about nature and technology.
Thanks a lot. So that were the reports from the 4 panels. And Angelika Epple is a member of the scientific board who was organizing this conference. When we started yesterday, you posed some very fundamental questions, especially on the differences of the disciplines and of their way to deal with theories. Did you already find answers?
Well, I feel that the keynote speeches in a way set the scene for the conference, and this in many different respects. I feel, as has been mentioned already, that the idea that quantum theory doesn't build a laser became like a metaphor why we need a mixture between different theories of different scales, so to say, and that this really was very convincing, as you showed it in an example, how different theories of different scales were very productively mixed. And I experienced this in different panels because I did panel hopping, and I felt that as well in the sociologist panel we had this mixture of different approaches that led to a new approach when it comes to globalizing developments. And I also experienced that in panel D, where 4 different approaches were mixed to explain the individuality or personality of different animals. So I found that very directly substantiated. And also the first keynote, who made us aware of the fact that it is very easy to zoom in very, very deeply, and that it is also very easy to zoom out very, very far. So both sides of theories are maybe easy, but in the middle there's something that seems to be more difficult to explain, and I feel that is where life is happening. And as a historian, I'm interested in that part. And this becomes even more difficult when it's about past life. And I'm really still wondering, and now I'm coming back to your question, I'm still wondering how this really does apply to the humanities. And it might be different for the social sciences and the natural sciences, but I still believe that it is really very difficult to transform this idea of causality to times bygone, but maybe also to other humanities than history. We do not have labs, so we cannot really repeat specific situations. Of course, we can try to explain a specific situation in its individuality, but individuality always refers to something to be compared with or against which background it is individual. So you need a theory, and as you have mentioned that in the humanities, I think we are more or less at that point that we've learned that the great theories, you said with a capitalized T, are overcome, but we do not still see what we make out of it. So I would say the situation is quite differently in the natural sciences, in the social sciences, where they are, as we've just heard, are going to find out how to build up a new great theory, and in the humanities, where we maybe still do not see exactly what would be an adequate answer. In the natural sciences, well, I don't dare to say too much about them.
Okay, thanks a lot. So the topic of the conference is a theoretical university in the data age. So we learned already, we have lots and lots of data, and we are drowning in data, and so we are looking for machines to help us sorting this data. And Professor Beenakker, what does it mean when we have big data and use machines and use machine learning to analyze big data? Does it mean we need less theory, or does it even mean we need more theory to get some order into this huge amount of data?
Well, I would say that the main thrust in that area of machine learning is to understand the reasoning which the computer took to arrive at your conclusion. Take medical science. I mean, there's now a big issue. Can we trust a neural net, a machine, to tell us which treatment is most appropriate for a certain cancer diagnosis? It has all the input, your whole personalized history, and it will tell you this drug is best. No doctor would dare to follow that if it's just the outcomes of a black box and the doctor is not able to follow the reasoning. So the big challenge there at this moment is to somehow make the machine, if you wish, more human, more thinking like us, so that it can explain, because of this gene thing, because of this allergy, I think this particular treatment is appropriate at this moment. This is in particular crucial also in the United States at this moment, where there is a big discussion whether this can be approved, whether algorithms can be approved by the medical association, like certain drugs which are approved to make diagnosis. And so this is what is lacking at this moment. So the research thrust, so this is more theory. It's because this is what theory is, right? Making sense of explaining why you arrived at a certain thing. And so the machine is a black box which looks at the data and tells you, like an oracle, this is it. That's not satisfactory. But we'll get there. I mean, there's lots of, it's not the idea that somehow machines will never be able to explain to you how they arrived at the reasoning. That is, I think, untenable. We'll get there, but we'll just have to improve our methods. And so, yes, we need more theory, and we're very much aware of that, because there are certain decisions which we'll only trust if they can be explained to us, and we will not be able to act otherwise on them.
Mm-hmm. Okay, maybe can we step one step back? You said we need the theory to make learning systems more explicable so that we can understand what they do. But when setting up these systems, it's always talked about them like you simply give them data and they come up with a result. You said it's a kind of oracle. But is it true? Is there really no theory behind setting up these systems? Is it so easy? You give them the data and they come up with the results.
This is what professors of computer science do, right? And no, absolutely. This is, but it's just like the knowing the architecture, which is what you design, knowing the architecture, the process by which you go from data to your conclusion, that is hidden in this vast. We humans have sometimes the same things, right? Where we make decisions in life, and not always can we exactly explain why we do that, right? We give things like it feels good, or intuition, or some people go to church and they're quiet and then they know the answer. We also are not always able to explain big decisions in life. And that's okay if it's our personal thing, but with computers, in particular also when it comes to profiling, which at this moment is one of the big issues in my country, using computers to decide who will be the tax office, who will be audited. It's the danger is that the computer will somehow infer that people with a certain last name, because it's from a different country or whatever, or with a certain background, that they will be audited. And even though there may be a reason for doing that, we will not accept that as a society. And so we absolutely want algorithms to be transparent. And this is computer science, and this is the main challenge at this moment. Yes, there's computational power, but the main challenge at this moment is to have machines be more human. We all know that we may have an instinctive bias. We all know this, of course, with the man-woman discussion, that we cannot instinctively assume that if there's a bunch of people here and the women are the secretaries and the men are the professors, we cannot so we've been trained to do that. And we must be absolutely certain that the computer does not somehow make this crazy inference. And so we want them to be more human. Computers should be more human, because that's the only way we'll be able to trust algorithms.
Mm-hmm. Okay, thank you. So when automated decision-making systems are applied to society, they have to be transparent. But what about science? If these automatically running models come up with results which are, in a way, trustworthy, but we are not able to understand them, maybe Professor Gölzhäuser, there are people who are already talking about a new dark age which should be coming up with these intransparent algorithms. Is there a science coming up which we no longer understand?
Yeah, I don't know. I think you made a very well point. We have to understand the algorithms. We have to understand what the machine does in order to use it well. And as I said before, as experimental scientists doing physics, chemistry, biology, and building technology with these science and with this knowledge, I think we take a very practical approach towards this. There are definitely algorithms and points where computers are the better predictors than all models. And I think this is, of course, then the case to say to some models, maybe we cannot use them anymore for predictions because other computers' algorithms predicted better. And we have to accept this. But on the other hand, I think there will also be models that will survive because beyond this purely predicting something to happen, they show some insight into the phenomenon. You know, that, like, a good example out of physics is optics. You know, optics is quantum theory, interaction of light with matter, with photons, electrons, and all these things, very complicated. But optics is also geometrical optics, where the craftsman makes the glasses, makes your reading glasses, and he approximates the whole optics with a single number, which is this index of refraction of this material. And this is a model that also gives some insight and helps you to doing practical things. And I think this will not go away. This has not gone away, even if it can be calculated by current computers. So in this way, I think maybe some models may disappear, or they may find a new role. But on the other hand, if we understand the algorithms, as Paul Humphreys has explained it very nicely this morning in our panel, I think there is no big problem. There is a practical hands-on approach to the solution, and this will add one more toolbox for the craftsman to make the technology or the science as it is required.
Mm-hmm. And you're not afraid that you are no longer understanding what is going on?
Well, of course, on the first sight you are maybe afraid. On the other hand, you can learn something about it. I think we had this morning in the first talk this discussion where a young person asked about doctors, when they get a lot of diagnosis from the algorithms, eventually they can get an intuitive feeling on how this algorithm works. And this may help them in their own medical profession. And I found this was a very good example. For me, it reminded me also like driving a car, for example. You know, when you don't know thermodynamics, you don't know the second law of thermodynamics and entropy and so on, but you can, when you drive a lot of car, you get an intuitive feeling after some while for this machine without knowing all of it, and you may be able to operate it. And probably, I don't know if it's a good example, I just made this up in the last two minutes or so. driving a car versus computing, one has to think if it's a good example, but it shows that people are probably able to adapt on a certain human level to new technology. And this may happen with artificial intelligence the same way, I don't know.
Okay.
Probably.
So you don't see a dark age coming up?
Well, not automatically at the moment.
Okay. Carlo Spoerhase, you started describing how digitalization changes your field. Do you also have to think about such problems dealing with intransparent algorithms? Is that a topic for literary studies?
Yeah, it was a topic during the talks, and we talked about it. It's really, I mean, there are people who know the algorithms, who do the coding, and the question is how much actually do we need to know as philologists, for example, to work with this? Do we also have to learn coding and so on, or is there a possibility to design these instruments in a way that allow people who do not have this knowledge to use this material and to use the algorithms in a critical way. So not just using them, playing with them, but somehow also having the ability to evaluate how the mechanisms work without actually knowing how sort of the fundamental principles how they work. So it's a bit like the car, actually. Someone would have to build the car. These would be the digital humanists, maybe, and they would know how this car actually works, and if it breaks down, they would know how to kind of make it run again. And then there would be maybe the philologists who use the car, who have some idea how it works, but not a very detailed idea, and who somehow intuitively and to a certain extent also critically manage to do something very interesting with it. So yeah, I think it really points in the same direction in a way.
Work on it.
Yeah.
So how's your feeling about digital humanities? Is that the new thing everyone has to jump upon? I mean, can one be still a classical philologist?
I very much hope so.
Okay.
I very much hope so. But yeah, I mean, it's new, and I think for a long time there was this very fundamental question if there should be digital humanists as a discipline. Should there be digital humanities as a own sort of intellectual field, or should the digital humanities always be attached to some already existing discipline? And as it turns out, it seems that the direction right now is leading that we're going in this way, that the digital humanities are always attached to some very concrete field. And to me, this seems to be also the sensible thing to do, to kind of have departments where there are maybe professors for digital humanities who are in very close contact to people doing history, doing philology, doing archaeology, and so on, and kind of working together to build these new instruments. Yeah.
Okay. So there's not only digital humanities, there's also digital social science.
I heard of it.
So how do you feel about that? Do you have to engage in this, or?
Yes, I do think. My personal view, we didn't really discuss this in the panel much, but my personal view is it adds to the repertoire of methodologies that you should know of if you do empirical research, right? But as Carlos pointed out, obviously we are not in the situation to really deeply understand the technology behind it. So we have to trust, or put a lot of trust in the people actually providing these instruments for us. But I think if you see it as a methodology in the social sciences, theory becomes all the more important as the tool that you have to direct your attention to things, right? So in our panel, actually, there's a suggestion by Julian Go, who is talking about globalizing social theory, is to think of theories as maps. And the point of a map, of course, it's selective, right? You can have many maps of Berlin, that was his example, but if you want to say of the transportation lines or of the buildings, whatever you're interested in. But if you put them all together, it's Berlin, right? It's no longer a theory of Berlin. It's the very thing. So theorizing always means to be selective, or you could also say it's a language that lets you express some things but not others. And that was actually then, that means that it's not so much about the methodologies and the data, but what do you make out of them? And what do different theories make out of them and see with the same data in many cases? They're very different things. So the plurality actually then of theorizing comes up as the main problem, as the problem. How do we have a conversation between different theories using different maps to see the same social world?
But does it really, this is an interesting example, does it really work in this sort of additional way that you have these different theoretical perspectives and you put them together and then you have this kind of unified model which actually matches reality?
Yeah, I mean, you could talk about maybe integrating one or two of these maps, right? Something like that.
Yeah.
But if the more maps you add to each other, you get a complexity that isn't really helping you see things, but complicates things in the sense that you maybe won't see anything. So it's and theory always is selective in a certain sense, but that's all. Actually, the discussion that we ended our panel with is, so how much integration is actually possible between different theories? But my point would be, I'm working on my theory, but I'm using the other theories to help me expand my sense of attention for things, right? If I have a theory of society where there's no race in that, for instance, and now Julian Go presents me a theory of society that is based on the distinction of race or racial hierarchies, then I have to think about what to make of this topic in my own theory, maybe with my own instruments, and that might look very differently, but it helps me expand my imagination. And I think that's what plurality of theories in the social sciences is all about. You have to read the others too, not to just merge theories, but to let yourself be inspired by these others to work in new ways on your own.
Does that also fit to history?
Well, what do you mean with this?
The idea of merging, of being inspired by theories of colleagues?
I mean, in that respect, yes, I would agree completely, yes, of course, yeah. But, I mean, speaking of digital humanities, I would say that, yes, it is a tool, it's a new tool, and it's an important methodology that opens up new possibilities. And it hits in the core of what we call source critique, because you need, of course, a new knowledge about how to criticize sources when they are generated with the methods of digital humanities. But I would say that it does not, at least as far as I see by now, it does not really help in finding new theories about historical change. And there, I think we might be a little bit braver to do the next step and try to find new ways how to combine different approaches that would not repeat the shortcomings of the great theories, which really pointed into one direction theologically, but that would somehow be able to integrate at least more different theories and try to combine the idea that history is never predictable. It could have come differently, and that's really very challenging for a theory of history, that it has to integrate something that is open to contingency. And if you want to find something like that, then you really have to be, I believe, integrative to different approaches, theoretical approaches.
So is there a principal difference between how theories are used in the natural sciences and in history and sociology and humanities? If you, both you're natural scientists, if you listen to humanities here, do you think that something different?
The issue of contingency for us is very much important, because we know this universe, it seems like it's designed for us. Everything works, and there's stories, if you change the fundamental constant just a little bit, life would not be possible, at least not life as we know it. So it's just an accident. Was the universe created for us? Or are there, which is this ultimate, let's say, failure of predictive power, saying there are billions of universes, we happen to be in the one where it's okay, and there are billions of others where it's not okay. Basically, you give up. I think many, I'm pretty sure also Professor Dijkgraaf would agree, would say then you're giving up as a scientist to explain. So we hope to be able to explain this contingency, and we have still some hope that it will be that there's some theory there behind everything which will explain and say, no, the only way the laws of nature make sense is with these values of fundamental constants, so that life actually is possible. And then, of course, you can still ask, and that's the big puzzle which we have as scientists, why is the world predictable at all? Because we can very well imagine natural laws which are not predictable, which make no sense, which are random, which could be different in different places. Here they're like this, in another galaxy the natural laws are different. So there is some design and understandable stuff in the universe, and we very much like to do away with contingency. Let's say the difference between physicists and biologists. We know in biology evolution is very much a contingent affair, but we hope somehow that we can push this away in physics, which is the ultimate aim for theory, I think. So.
Yeah, may I add to this point? I think in the panel this morning there was often referred to the plenary talk of yesterday evening, where Robert Dycraft nicely showed this plot, this sort of like a Gaussian curve. There is the theory of the very small, this is very rigid, and there is the universe, and we have great theories, and we may never have a theory for all the big stuff in the middle. And I think this is probably true, and as I said, we are the craftsman panel, so to say, when we want to build technology or when we have a certain mission to fulfill, we use the theories or the models or the things as they come. And I think this is an attitude, this goes, and I think this is probably the spirit of this breaking confines thing. This is adaptable in many disciplines, also beyond the natural sciences. I think also in the social sciences, there is, of course, a manifold of theories, and it may not be really too great to look for the one unifying, perfect hyper theory that eventually explains everything, but rather than look at small, well-defined problems, develop theories, and then sneak around maybe at your neighboring discipline. Even in the sciences, there are many overlaps in methodology between economics and biology, and so on. There are models moving around between these different disciplines. So as far as handling the theory and then also the introduction of, let's say, a new tool like big data, there may not be so much of a difference between the natural and the social sciences. Maybe this difference is more made up than it is real in practical working.
Well, if I may answer that in respect to history, I would say that it is very difficult to find a theory to explain that in the middle. But if you do not try to find a theory, then what are you explaining when it comes to history? So if history is about explaining historical change, you should somehow dare to find a theory that would explain it. Otherwise, it's just that you can explain maybe a situation or a specific context in a specific situation, but you cannot explain how all the history came about. So, and the problem is that the theories we had are not convincing any longer. And this is more or less the situation we are in. But if you, at least I think there are many historians in the room that would have a completely different opinion about that. So, but at least I'm personally convinced that if we do not try and dare to do the next step, in a way history becomes meaningless and it's only a presentism. And then you can explain different situations in different historical contexts. And it is interesting to have that and to have a model, as you would say, for explaining this specific situation. It helps you maybe to reflect anew on your own situation, but it could also be ethnology.
Well, there is the search of the theory of everything. I don't really follow so much these efforts to build the big theory. Of course, this is a valid point. If is it the purpose of science and research to eventually at least define the theory of your discipline or so? Maybe not of everything, but maybe of your discipline. Maybe yes, but maybe no. Maybe it's also fine just to do craftsmanship and to gain insight along the way and then create technology, and by this way, well, do your thing. I'm not so sure if we really need that. But I think this is a point every scientist has to answer themselves.
I just would like to add, I do not want to explain everything.
Just history.
Just historical change, which is different.
Yeah, but maybe there's still this dream in the back of one's head that maybe there is a theory which brings everything nicely together, and that nature at least is in a way systematic and understandable, and it's possible for us to grasp it.
May I just add one thing? Because maybe their sociology and history and the humanities are aligned in that at least I think what we could add to the discussion is some sense, maybe consciousness of the historical conditions of theorizing, our own, but maybe also other, right? So that's why we need a philosophy of science and a sociology of science in order to show that each theorizing project has a historical origin that in some sense determines what it can see and what it cannot see. And I think that was also a point made by Julian Go in our panel. He called this the provincializing, the provincial roots of global theory, right? So that every kind of universal point of view on the world is born out of a certain perspective, a standpoint that it cannot really overcome, so that the one might see racial relations where the others might see differentiation and progress and so on. And the interesting thing is then that if that is something that you cannot escape, but you can still do it, right? But you have to be conscious of the limitations of what you're doing. And I think that is what I find really important as a sociologist. That doesn't mean that it's, that you shouldn't do it anymore. It just means it has to be something that is limited, and you should be conscious, or it is something that is limited, and you should be conscious of the limitations of what you're doing.
Yeah, and as you said before, it might be the case that we are not even able to do it ourselves. So there's this necessary dimension of plurality, right? Where someone else will point out where the provincialism actually is, because we can't sort of step behind our back and look at our own provincialism. So in a sense, this is really a sort of plaidoyer for the plurality of the humanities. Yeah.
So we heard a lot about theories on different levels. It seems to me that at least in the natural sciences, the very big, the grand theories are kind of stable, like quantum mechanics or theory of relativity, and theories on a lower level or even models are discussed and are more fluent. Is there, first questions would be to the natural sciences, is this idea or this impression, is it true that there are some grand theories which are more or less undebated, which are fixed?
I dare to say no. I mean,
okay.
If you just, yesterday evening we heard about dark matter. People are searching for dark matter. My colleague Erik Verlinde in Amsterdam says dark matter does not exist. It's the big fallacy of the 21st century. He's taken seriously, and we'll just so. But the way we somehow work is we never throw away stuff, because a new theory will always, the old, like Newton's law, 17th century, they're still okay. If you want to build a spacecraft, I mean, that's the laws you follow. So it's not that the building is disintegrated. We dig down deep in the foundations and see that something has to change, but the house itself remains the same. And so it's pretty, one can be pretty certain that 100 years from now will look very differently than we do today at fundamental laws of nature, fundamental particles. But that we'll still be designing aircraft in the same way, and we'll still have maximum speed of light. So some things, I guess, are non-debatable. No energy out of nothing, maximum speed, no time travel. I think that's somehow undebatable. But much of the stuff which we don't understand will it's not just the small things, it's the big things, the big questions.
I can fully agree. If we would have this discussion 120 years earlier, we may have still believed in ether theory, that the ether was the medium, and it turned out till special relativity that it was not, and it was actually proven by an experimentalist, by Michelson-Morley experiment, by experimental physics. It was proven that, this was the key experiment to show that the ether does not exist. So on this level, of course, you may question also quantum theory or relativity or something, but again, relativity is around over 100 years and quantum theory almost 100 years. So you really need to question very hard. And here's, I guess, one point that is maybe special to physics, that you can do experiments. That you not just have your theory and to do it, but that your theory is about objects where you can really do experiments and where you can also falsify a theory. And most physicists are happy when they can falsify it. If you would falsify relativity, you would get a Nobel Prize. Absolutely, no question. So this feedback loop or this experiment as an additional stimulation for theory that is, I guess, special to the natural sciences, but I think that keeps them also alive and allows us also to accept that some theories may be considered very valuable and may live very long. Others have a shorter life.
Mm-hmm. So does it mean that the main theories in natural sciences are old? You mentioned they are all about 100 years or so. Are they new grand theories, or are you still working with old stuff?
This is a major difference with. So I teach electromagnetism. That's 1880. Can you imagine, let's say, in a psychology department, that the theories which you present to people are Freud or even older? People will laugh at you, right? Say, what an old-fashioned university. But yes, I teach electromagnetism, 1880. Newton's law, Lagrange. This is 1800, and we can be absolutely certain 100 years from now we will still have this old stuff, and this is something to be incredibly happy with. So this is an endeavor which does not decay. Most of the stuff we do goes away, right? Universities rise and die, and the building blocks of the natural sciences, they will. It's the closest to eternity which we can get here in our life. This is absolutely true.
I would fully agree. I tell my students as an anecdote, when I have freshman physics class in students, I say, I'm teaching physics 1, and you say it's 1880. I say, if you take a physics book from 1940 or from 1960 or from 1920, it's the same. You can still use it. If you have a biology book or whatever book, sociology book, you have to always get the latest edition. But if you go to a used bookstore and get introductory physics from 1955, use it. It's the same text that
So are you proud of that, or are you thinking that you are not making progress?
I think it's an achievement. I think it's a civilizational achievement. You may say it's no progress. Depends on your perspective.
Okay. I'm somewhat stunned, because I always expected that from your point of view you would say everything is new. We're doing it's super fast innovation and so on, because like typically it would be the humanists who say, well, we are doing work like philological work like in late antiquity, right? So this is a long tradition going back to sort of very, very good practices and methods established 1,500 years ago, maybe even earlier. So how does this sort of relate to what you were?
I don't see a contradiction. I say when I'm doing nanotechnology, we are developing new membranes for special applications in technology, in filtration, and elsewhere. But we rest, of course, on a solid foundation of our discipline. There is no contradiction of doing really new stuff, but based on science, on principles that was developed 100 or 200 years ago, or 50 years ago.
I'm really happy to hear that all of you are historians.
I just want another idea that I just had is obviously you have the unfair advantage that the universe is changing a little bit slower than society, right? So we have to be a little bit more up to date than you do.
So that seems to be a funny result, that those who are expected to sit with old books in the libraries seem to be much more advancing much more faster than the natural scientists teaching with books from the 40s or 50s. You mentioned, at least those from the humanities, that somehow you hope you don't have to go too much into detail with all these new techniques with machine learning and data science and everything. What would you recommend your students? Would you recommend them to learn about these practices? Or would you prefer to hire someone from the informatics department and let them do the stuff?
Well, I would recommend my students to go to my colleagues who really know something about digital humanities to study it. Because, I mean, we are not only educating later scientists, but also people that really, after studying history, try to find a job outside. And I believe that it is a cultural technique, becoming a cultural technique that influences really many professions. So it is very useful to understand a little bit more about it than, earlier.
Just to add to that, I agree. I think there's just one thing that seems to be important to me, and we're discussing this with Silke Schwand, for instance, who's an expert really in that field, sitting over there in this SFB practices of comparison. So we're, for instance, in our project on rankings, we're interested in these tools, but of course we don't know that much about them, so we need assistance. On the other hand, I think that there's a real danger of these, say, digital humanities or digital social sciences developing into closed fields of their own, right? Because you need interesting questions to make sense of these, or to actually put these methodologies to use. And these questions have to come from the disciplines that are using them. At least that would be my preference. So we don't need disciplines of digital humanities. New discipline, we need to incorporate it into that. What we're saying, that's a methodology among others. I think it should be and remain one, because it needs to be connected to the other methodologies and to the theories that we have. And that's a little bit of a danger I see, that it's maybe developing into kind of fields where it's only digital, right? And it's not connected to all the other good methodologies that we have.
In our panel, we also talked about the objects and how different the objects in the humanities are, and if that makes actually a difference. So if you're using this digital humanities tools and instruments, if you're trying to use them to analyze texts or to kind of analyze pictures or maybe analyze sound, maybe what you're up to will be totally different. So also in this case, it seems to be that there's also a close connection to the objects you're interested in the building of these instruments.
Mm-hmm. So before we open to your questions, maybe Professor Beenakker, could you imagine having projects in machine learning or other techniques together with people from the humanities? If someone from the humanities would approach you and say, can you help me to analyze, I don't know, sculptures from antiquity, could you help them? Would you be interested in doing such work?
So in fact, we're perhaps not as interdisciplinary as this university, but we recently launched a project which is called SAILS, which means something like artificial intelligence in the life sciences and humanities, something like this. So it's very much what our administrators want us to do. And I'm not sure that we could contribute, but this whole idea that we should, cross disciplines and work together is very much on my mind, and is absolutely something I would like to do. I'm not sure that I will be able to contribute. That's a different story. But this whole idea that disciplines can work together and insights from different disciplines can cross-fertilize, that's very much something which we're open to, yes.
May I add something? When you say what you recommend to students, I can only say it in German. I cannot really translate it correctly. Aber wenn man über den Tellerrand gucken will, braucht man als erstes einen Teller. Yeah? So I think this what you say is absolutely right. You should have interdisciplinary communication, and you should exchange ideas or something, but you should, of course, in the curriculum, let's say in the high school and also in the elementary first years of your university study, you should have some sort of a basis from which you can argue. So I would, in this sense, be even maybe a little more conservative of saying there is a reason that we have these disciplines. Why are there these disciplines? When you look for nanotechnology, this is chemistry and physics. What's the difference? The chemist learns how to cook and make the materials. The physicist has problem sheets and learn to do the math and get the electronics right. And these together make the nanotechnology. It's as simple as that.
So it seems to be that humanities have to have interesting questions interesting enough to attract people from data science to come up with all their possibilities and help to solve these problems. Okay, but before we start discussing the theory of interdisciplinarity here, maybe there are questions, comments from your side. Oh, lots of them. Okay, please. No, you first enter.
You said, Mrs. Epple, that you are, as a historian, are of course interested in understanding.
Kann man das hinten verstehen? Dann müssen wir hier mal kurz die Mikrofone austauschen. Kommt sofort.
Thank you. So, Mrs. Epple, you told us that you are, as a historian, interested in explaining historical changes. Of course, which is somehow the job description of a historian. But this question, Mr. Beenakker, goes to you. Do you think, or can you imagine that you someday have a set of data which is maybe big enough, put into a machine that is possible, big enough to explain historical changes, to have to explain, to recognize patterns in this? Let's think out of the box. Yeah.
That is there's this Isaac Asimov civilization series, right? This was precisely the idea that if the data set is large enough, you cannot predict the lives of individuals, but you can predict the rise and fall of empires.
Exactly, yeah.
I don't know. I mean, this is very much a futuristic. It's my impression, actually, just looking at the last century, that big changes were very much tied to butterfly effects. That's how we call these things. You know, some random event, something which has unforeseeable consequences. So it could very well be that actually chaotic dynamics plays a role in historical development as well. And one thing for sure, I mean, we've been talking about a quantum computer. A quantum computer will never be able to predict the weather, period. And it may very well be that in historical developments have something which is similar to the weather, and that are just things which amplify, which you will not be able to predict. That will be my guess at this moment. The answer will be no. Mm-hmm. It's chaotic.
Thank you.
So, and if I may add, if you could recognize patterns, I mean, that would really be a big deal. And describing is for historians already really, if they describe very well, they have done a good job. However, patterns do not explain historical change. You just see the patterns.
You're right. Yeah.
Maybe just one thing to add. Maybe there's just too much meaning involved in history, right? So that was, and that's really hard to model in patterns and anything else. So I think that's a very basic methodological problem that needs to be solved first.
Mm-hmm. Could you hand your microphone just behind you, yeah, and then you.
Thank you. My name is Carsten Reinhardt. I'm a historian of science. I want to challenge a bit the harmony that you present. Because in my understanding of theory, for example, versus experiment, right? Armin, you are an experimental physicist, and you corrected Manuela, Lenzen, rightly so. So there are tensions in disciplines between theory, experiment, instrument building, and I would argue in all of the disciplines that you present. So, and at the same time, there is also a certain tension inside theory. What is a theory? What does theory building mean, especially in the data age, right? I mean, is theory now simple correlation building, or is there still the same standard for explanatory power involved? So I want to know a little bit more about what makes you tick. How is the competition between these fields in your disciplines and between your disciplines, if you can say a little bit about that. Thank you.
Who feels addressed? No one dares. Maybe you start?
As a non-physicist,
Was the question about how the relations between
the relations
disciplines?
between all of the disciplines? Because I thought this was more internal natural science thing, or was I? No?
Social theory and practitioners in our fields. I mean, don't you think that there is here tension?
Yeah, actually, we were discussing in our panel one tension. Not really discussing, but Sina Farsin presented the difference between genres in sociological theory. For instance, many of you, if you don't read sociological books, you probably know sociology mainly from certain publicized, very well-publicized books like The Risk Society or Quantified Society or the Society of Singularities and all of these societies, right? Which in the sociological world, so to speak, are a very specific genre and not really theory from the perspective of many sociological theorists. And then the question is there really a tension between them? And actually Sina Farsin had a distinction between different ways of seeing the distinction. One of them is actually substitution threat. Right, so that would be closest to what you described, that we see. So these kinds of simplified versions of sociological theory, kind of substituting the real deal, so to speak, in the public eye and then maybe also at the universities. But in my perspective, that's not a realistic view of the relationship. You can also easily see this as a complementary relationship that maybe is even good for sociology to have, in the sense that you have some public sociology out there and then specialized theorists, and they both can learn from each other. But you're right, it's not clear that the one will out over the other, right? That's a struggle within the discipline itself. So that's one of the things you could think of in terms of conflict within the discipline.
Well, I think talking about nanoscience and technology, for example, I don't see a real hierarchy. You said instrument builders, experimentalists, theoreticians, you can do simulation people or so. Of course, well, I would put instrument builder and experimentalists in the same category. They are the same sort of people at least I would guess so in my own field. I think it's just as long as you treat a problem and you want advice. If you do an experiment, you can't explain it. You go to your theorist and he has a theoretical model, say density functional theory or something, and develops then a model where this atom goes, why this bond forms and this other bond does not form. This can be very synergetic and very productive. And as I see in my field, in the practical way, a lot of collaborations of theoreticians and experimentalists, as long as they face the same problem. Of course, there is a difference between when there is a theory, you know, in cosmology or in particle physics and an experiment in condensed matter physics. There is, of course, less interaction. But if they face the same problem and they're one team, I would guess, in most cases and in reality. And most of the leading institutions, you have people with different backgrounds or with theory and experiment working together. I don't see this problem so strong. If they have a common goal.
Mm-hmm. That's what we also experience at the Center for Interdisciplinary Research. When there's a common problem, then interdisciplinary works. If there's only the intention to do something together, then maybe it works less well. Could you hand the microphone to?
I already have them.
Oh, great.
Yeah. I want to come back to the
self-organized public here.
You hear me? Yeah? I want to come back to the original, so the theory in the data age question generally. And I'm an economic theorist, so I had to always defend myself as a theorist. What do I do? And I felt that first I want to challenge the idea that we have so much data. So I mean, as economists, so what economic theorists are interested in, there are like things like, how should a country choose a government? And there is an infinite number of possibilities, and not all of them have been tried, in fact, and you cannot run experiments. And in fact, for me, the way I see history, so there's one historian once gave a definition which I think you probably won't like, which is just one damn thing after another. And if you see it that way, then you really haven't tried everything yet, right? So I would say that if you go back what I would have liked this data, I would like to have evolution of the world 1 million times, or even more than that, right? But that's not something we have. So I feel like if I want to think about what government should we choose, how should we choose government, what procedure should we use, we've only tried very few, but there's infinitely many. And so theory building seems very useful to try and identify how we evaluate things that we have never tried. So similarly, for example, later you will have this apparently that you're going to think about how grants should be given, how should science be financed, okay? Now, we have not tried so many different things, okay? And there is an infinite number of how we could allocate money to different scientists. Okay, so I could give everything to you, I could everything to me, I could give it to, and we could do it as a basis of output of some kind. So that's why I think theory really is very valuable. So maybe let me add one last point. Do you hear me? Is it? Okay. Yeah. So I want to add one thing. I also think that theory is useful already in the very beginning. How can you do data work without theory? So what does it mean to do data work without theory? So suppose you're interested in the unemployment in Bangladesh and you want to understand how unemployment in Bangladesh comes about. If you have no theory, then you should collect data about snowfall in the Rocky Mountains. And there could well be that this happens to get somehow correlated. So even there at this stage, right, you need to do theory. So you don't do theory, for example, where I say, I don't do an experiment where I think about letting a ball drop in a high tax country or a low tax country. Because you realize that because of theory, there is no interaction because of these things. So these are my main reasons why theory is useful, in my opinion.
Okay, please, maybe I add one organizational point. Professor Beenakker has to reach his train, so he unfortunately already has to leave. Someone want to comment on this, or we leave this as a comment, or maybe you take this question to the next panel, which is about how to organize and have the political discussion about science? Okay. So,
maybe I can, just because you said this would not maybe fit my understanding of theory of history, I would say what the difference is, and the question you pose and what you want to get out of your data is completely different. I mean, as far as I understood, you're interested in what works. That would never be a question of a historian.
That's fine, I think, yeah, but one can be interested in a question as what would be a good way of choosing a government, right? And there's millions of ways to do it, and the theory can help maybe in identifying what would be useful.
Mm. Okay, so who?
Thank you. I have a question to Professor Gölzhäuser, because you came up with the metaphor of being a craftsman of model building. But it's a question to all of you panelists. Do you see sort of a common theory or a common language of theory building in terms of a meta-science or something like that coming up? Or does it stay with discipline by discipline? Because, as you all pointed out, you have very specific questions that are only original to your original discipline. So is there something like that?
Well, just very spontaneous, I can say maybe big data, who knows what will happen in the future if these algorithms are valid in different disciplines and can be used, and if this methodology is now neutral. It's like the computer and simulations, which is also worked now in many disciplines, in physics, in chemistry, biology, and also in the social sciences. So why not that big data may be a next common tool in the toolbox of the craftsmen of the different disciplines, craftsmen and women in the different disciplines.
Maybe just a remark from the sociological perspective. There's actually a discussion in sociological theory about the meanings of theory. There's an article by Gabriel Abend, an American Argentinian sociologist, I think, who distinguished a number of meanings that you find in sociological texts of theory. And they're very different. And his conclusion was, and I agree with that, there are very different understandings of theory, but try to make explicit what your understanding is while theorizing. Are you trying to create a language of concept that fits together, in a systematic fashion that is different from just producing a hypothesis, for instance? You're just saying, I want to have a question about some phenomenon that I have. So to very different projects, they might fit together, but they're usually doing one of the two, not both of them at the same time. And that applies to other meanings of theory as well. And I think that is something that actually other disciplines could maybe use, in the sense that you need a certain, meta-theoretical understanding of what the meanings of theory in your disciplines are or could be. So you could and try to make explicit what you are doing while doing theory.
Okay. Okay. Next.
I want to come back to one point in the panel discussion when you were surprised that physics seems to rely on theories dating back to the 19th century. And you mentioned that in humanities it might work faster. So what I think is one of the reasons for that surprise is maybe a misunderstanding of terms. If we talk of models in physics, these are developing very quickly, and if you do nanoscience, you develop a model a day, I would say, to go forward in your discipline. But we rely on theories. So what I'm a bit confused after this day is how we use the term theories in the different disciplines, and maybe it's a good point to be clear about that. Do we talk about model for a historic development? Is that what we understand in model, or is there really a theory in a sense as we use it in quantum theory that you're looking for? So I'm a bit confused about that after the panel discussion as well. I would pose that as a question to you. So what is there a different meaning in these, how we use the term theory?
Okay, hier direkt dazu, hier in der ersten Reihe noch, dann... After that, okay.
I always get confused the same way, but this is the problem. I guess there is this unique selling point in physics, which has these more or less generally accepted long lifetime, 100 years and longer theories that go on, and so we make the distinction between theories and models, whereas in other disciplines you may call the models theory, but I always get confused. I can fully understand you. Sorry.
That's what I meant, right? Try to make it explicit. And then if you say theorizing as modeling, that's different from inventing a language to explain everything. So, and if you do the one thing, you're not doing the other. And if you make that clear, then maybe we have less confusion.
Yes, earlier in the discussion we had the question that if there is a conflict between theory and experiment. I'm talking now from the point of view of a physicist or of natural sciences. And of course, we all agree that on one side we need both. We need experiments and we need theories. But I think the harmony here is a little bit exaggerating, because there are conflicts, not only in physics. I remember when I was a young student, I once listened to a physicist named Anderson, and he was a specialist in finding superconductive material. And I remember saying that one should forbid to all theoreticians to predict where you would find superconducting material, because they were all wrong on misleading the experiments. Now that's sort of, this conflict even existed in physics, but if I'm talking about social sciences, I mean, we had in our history quite a few theories which somehow were not only not useful, but dangerous or misleading the world. In this respect, I'm not quite sure whether it's true that there is this harmony between the two and we need both, but sometimes we have big conflicts in terms of theories which are developed without having the touch to the ground and without having the empirical background.
Yeah, my name is Rano Kliegel. I'm an experimental psychologist, so I just one brief comment first, that when I teach color vision, I start with Newton, Maxwell, and Helmholtz in terms of theory, and the foundation of vision and hearing is still Helmholtz. And I think some of the things that I also want to say then is really the distinction between theory and modeling. And the point, and that comes then back to a question also to you, is that I think in experimental psychology or theoretical psychology, we start with theoretical principles, which can be general, can be very formal, but then in order to test the coherence of our thinking, of our theoretical principles, I think there's now general consensus that we really need to implement them as computational models. And implementing them as computational models requires skills that really go beyond what we usually teach our students. It requires knowledge of differential equations, it requires knowledge of nonlinear dynamics and stuff like that. And I think in my area, you will not really find a very important, impactful paper that's sort of shaping an area that can really be done without the cooperation of experimental psychologists who come up with the data that really then are sort of, test the coherence of your thinking, if you want, in the context of a computational model, and computational scientists coming from mathematics, computer science, physics. And so coming back is because there was that question before about what role does computer science is going to play in the humanities. How do you want to have them? And there was sort of a little bit the idea, well, they give us the methods and then they apply them to our data. And my prediction is you will not become very happy with that perspective. So in a way, you need to sort of somehow embrace the theoretical principles underlying these new digital technologies, these new computational algorithms, and at the same time, from the other side, the people working with you, they need to understand the theoretical principles guiding your research before they can really come up with good implementations of what you're after. And then you really sort of get the tension within the disciplines, and within my discipline, it's very manifest, I would say. Should we really teach, and I would be in favor of that I would think that our undergraduates should really be taught differential equations. Because I think you cannot really come up with any important theories in the future without a solid notion of these topics. And we cannot farm out this kind of competences to a different discipline. We have to have that as part of our discipline. And at the same time, of course, there is the need for specialization. And in psychology, of course, there are many fields that do not need differential equations. If you want to become a psychotherapist, I wouldn't want to torture people with that perspective, with these kinds of techniques. So, in a way, have you thought, it's really sort of to the humanities here in the panel more, have you thought about that tension of when you integrate these new ways of testing your theories in terms of computational models, the kind of competencies you need to have in your field and what you need to recruit, how you balance these kinds of demands?
So it seems we have natural sciences distinguishing between theories and models. We have the humanities talking about theories. So the two are using the same word but different concepts. And so is it your idea that computational language can be a kind of shared language, that when we turn to computational models, maybe there is a kind of shared language in between the two?
Actually, I would prefer to keep the difference between the theoretical language, which I like the example of the maps, theories, or I'm quite, I think, very close to also Nancy Cartwright's perspective on that we need theories for special purposes, we use them. And I really sort of think about the computational or the models as attempts to implement in a coherent way something that can be deduced or derived from the theoretical principles. And that implementation question is, of course, an extremely complex process by itself, and any theoretical principle can be implemented in an infinite number of ways, and the decisions you make will in the end decide also whether you get a coherent feedback from your results. And so this issue, I think it's important to distinguish between theoretical principles and guiding your research, motivating your research, and the way you implement that in concrete experimental settings. And this tension, I would not sort of just want to muddy the waters in that respect. But
so do you feel you should distinguish models and theories?
I think when talking about models and theories, we were talking about different meanings of theory, I think. And we are talking now about the relationship between theory and empirical research, I think, which is not the same, in my understanding at least. And maybe to come back to the question, when do theories become dangerous, right? I think the question, at least for me, is one of being sensitive to what empirical research tells you as a theorist. And you can react in two ways. You can say, all the worse for reality, right? That it doesn't fit my theory. Let's go on with the theory. Or you can try to build and reconsider your theory in light of what empirical research tells you. But I agree with you that what you find out in empirical research is always co-produced by theory, right? So you can only see that what I meant with the earlier remark on the theory as a map or a lens or a vocabulary. You only can do this research because you have the theory. But then the research has to inform your theory. It has to be able to be wrong, right? So, and that's, I think, what good theory is about. And there's lots of theory in the social sciences that is maybe not up to that standard, in the sense that it tries to be immune to what others may find out in their empirical research.
Anyone else?
Yeah, oops. Das war nicht meins jetzt. I think it's clearly different concepts of theory that are in play here, and from the perspective of the philologies, for example, a theory would be like a theory of language, maybe. So if you look at an artwork, a text, maybe you would have some very general idea about how language works. Then you maybe would have some very general idea about how artworks work. And so on, and then you would have certain methods, you would have practices, you would have maybe ways of looking at things which are not strictly theoretical in this more general and abstract sense. But of course, what we would call theory doesn't aspire to be, for example, a deductively closed system of sentences or something even approaching the idea of something like that. So it's much more, he before my colleague was talking about the house he was living in, and as a philologist, I don't have the sort of impression I'm living in a house that is sort of built up in the ages in a way and perfected, but it's rather different sheds maybe, and a much looser compound than that. Yeah.
Mm-hmm. That's an instructive picture, yes. So we are unfortunately running out of time, but before we end, I would like to start to ask our Vice Rector, what does it all mean for Bielefeld University? Is the idea of a theoretical university still up to date? Da ist noch eins.
I think, I believe the best thing that could be an outcome of this conference would be that it was maybe the first one for celebrating our 5th anniversary, but that it is the beginning of a series of conferences like this, because I feel that it really was an experiment, and I'm not from an experimental discipline, so I enjoyed this, and I hope that it would be possible to repeat it, because it has been one of the moments where we really tried to do what we can call big interdisciplinarity. And that, at least to my feeling, happens far too randomly, selten.
Rare.
Rare,
Really?
yes, exactly.
Yeah. Okay, that's a perfect point. Yes, we have reached the end of our discussion. I think we've seen one more time that digitalization, artificial intelligence, and all these topics are invading the different spaces of science, creating new methodologies, and at least bringing us to the point that we have to think again about our methodologies, about our concepts, and maybe even about the possibilities of collaboration between the different disciplines. And that's for a university which is set up for on interdisciplinarity, a perfect result, I think. So thanks a lot for taking part. Thanks a lot for listening and for commenting, and we are looking forward to the next panel. Thanks a lot.